Now, last period, we talked about what makes something an acid and a base. Now I'm going to talk about how you would recognize one if you were walking down the street.
Okay.
I know I can recognize an acid.
We recognize it right now.
I've had many over the years. But how would you know an acid from a base based on its properties?
Well,
Yes. It's a red shirt on. It's about yay tall.
yep, there you go.
All right. No, he's not that tall. Now, how would you know an acid from a base? Well, the properties. See if you can think about things that you know are acidic or basic, and see if you can figure some of these out. For example, I want you to think of things that are acidic that you eat. All right, I want you to think of things. I mean, without saying the answer, what you think. Think of stuff that you know is acidic. I've already tested a few things up here. Vinegar. I tested, lemons, orange juice. What is the main characteristic of all of those? How do they taste? Bitter and Bernie were the two answers I got so far. That's so wrong.
Orange juice. I say tangy.
Tangy would be better.
Okay.
Looking for another one.
Sour.
Sour would be the best. Exactly. Yes. Most acids have a sour taste. All right. The sour taste is actually not unpleasant to us. Many things we eat are acidic. All right. Not many things we eat are basic, which is why I was disappointed with the other two answers of, well, Bernie, that's just done that. But bitter, people don't realize the difference between bitter and sour. There aren't very many things that you drink that are bitter. There's not many things that you eat that are bitter, all right? Because you don't like that taste, all right? What you're calling bitter is actually sour. Orange juice, lemons, limes, those are all sour, not bitter. All right, and so is a vinegar, sour, not bitter. You're calling it bitter, perhaps, but it's not. Bitter would be something like if you've ever had baker's chocolate by accident. All right, not regular milk chocolate, but baker's chocolate. That would be bitter. Coffee without any cream or sugar. A very strong coffee. That would be bitter. Most things that you could think of that you like the taste of are sour. All right, obviously, they're also sweet or salty or other things too. But of the two choices between sour and bitter, which are kind of considered to be relatively opposite, sour is the more pleasant taste. There's a lot more things you could think of that are sour tasting. Sweet and sour chicken, sour Patch Kids candy things. All of those things are sour, and we like that taste. All right. So there's a lot of things that we eat. By the way, if you ever look at the bottles of antacids, they'll say on them to treat, it's right there, to treat sour stomach. The reason they call it sour stomach is very simple. If you've ever had heartburn, all right, and maybe you burped and some gastric juices came up from your stomach up into your throat, how does it taste? Or you've all probably thrown up at some time or another. It tastes sour, all right, because of what acid that's in your stomach. What acid is in your stomach? Hydrochloric. Yeah. That's why people, you have to be, obviously, it's not as big of a deal nowadays, but it used to be, like, I remember when it first came out, first diagnoses of anorexia and bulimia, where people would, to lose weight would make themselves throw up. All right. I don't know how much of a big deal it is now, but when I was a kid, that was a big deal. Like, there was, like, a new diet, kind of like autism is today. Like, it's all over the news and everything. Well, bulimia was back then, because it was like basically new. People were giving a diagnosis to it. But one of the things that people like that had a problem with was they were irritating their throat so badly, and they would become hoarse and doing a lot of damage to their throat because of the acid continually being regurgitated. Most of you guys may have heard of reflux, acid reflux. There's commercials for that all the time. And same thing. I mean, it's acid, stomach acid getting up into your throat where it doesn't belong, and it can do more damage. All right, so acids taste sour. Acids, as somebody mentioned a little while ago, corrode things. They react with almost all metals. Most metals react with acids. There are a few things that don't, but most metals react with acids. As we already saw from a little while ago, what elements usually in an acid? Hydrogen, yeah. They usually contain an ionizable. That is a hydrogen that can be broken off. Good. And what else did we just see? That I could tell an acid from a base to litmus. What do they do to litmus? They turn it red, yeah. Now, compare that and contrast that to a base. A base has a bitter taste. And like I said, bitter tasting things are not a pleasant taste to us for the most part. You've all seen the commercial bitter beer face, and you know, a lot of beers that are. If you guys, when you guys eventually learn or do drink, there are beers that are very bitter. Like some are like stouts, black beers like Guinness is considered a relatively bitter beer, and a lot of people don't like them. I mean, it's an acquired taste. Even a very hoppy beer like an IPA, not a Corona. Corona would not be considered a very hoppy beer, but an IPA. And you know, now the big thing is all microbrews. I mean, Berwick has a microbrewery, Danville has one, Bloomsburg has two. We have a lot of microbrews around here, but really it's a connoisseur kind of taste because there are people you go in there and like you'll see them, you know, try one of these beers and they'll be very disappointed. Like, I'm spending money for this. This is terrible, because a lot of them are very bitter. That's not a pleasant taste for most people. It's an acquired taste for the most part. You really don't like bitter. Why? Well, it turns out plants, like, well, somebody mentioned coffee a little while ago. Another good example would be tobacco. Coffee and tobacco and all plants have inbred, all right, in them, they have defense mechanisms. See, plants can't walk away. They can't run. All right, so what do they have on them to keep animals from eating them? They got thorns, you know, and they have a really bad taste to some parts that they don't want the animals to eat, like their leaves. And like maybe their beans, like coffee beans and leaves, like for tobacco leaves. Their taste like that, so that animals don't eat them. So what do? We smoke them. You know, we smoke tobacco and we chew tobacco and we grind up the beans and coffee and we make coffee out of them and, you know, water and everything for the effect. All right. Anybody that tells you they like the taste of coffee or tobacco, you know, I drink coffee. I don't smoke tobacco, but I drink coffee. But the fact is, I drink it with sugar and I drink it with cream. And the actual black coffee, to me, and I think to most people, give it, for example, just do this as a simple test. Take a 5-year-old, give him a coffee and a cigarette, and see what he likes better, that or candy. What's he going to do? He's going to take the candy. Yeah, don't really give a 5-year-old coffee and cigarettes. And better yet, while you're at it, give him some IPA beer, and you know, just call it a day, because that's, you know, if you're going to go to jail, you may as well go all the way for a reason. You know, coffee and cigarettes is enough. You just, you know. But what I'm saying is, they aren't really pleasant taste. Now, those of you, I mean, you're in honors class. I don't imagine most of you smoke cigarettes. You know, pack a day maybe, but I doubt it. Besides that point, but the fact is, people who do, and you see them outside, they're doing it you see them across the street. They're not doing it because it tastes good. They're doing it for one of two reasons. And if you're a kid, you're probably doing it to fit in and to be cool. But if you're an adult, you're probably doing it why? Because you're addicted, because there is a bit of a high, a bit of a rush that you'll get from the nicotine and from the caffeine for coffee, and from the beer, if it's alcohol, it's from the alcohol. There's a bit of a mood-altering drug to each of those things, and that's why you're doing it. You're not doing it because it tastes good, because bitter things, like bases, are a defense mechanism of the plants for the most part. They taste like that so that animals like us don't eat them. And then we do anyway. So, yeah, it's kind of weird. All right, bases also feel slippery. This is one of the things I will warn you about when we're doing a lab. I think I may have mentioned it a couple of times when we're doing the air lab. If your hands feel slippery when you're doing the lab we're going to be doing on the titrations, it probably means that you have some base on it. Bases are slippery. Soap is basic, and soap is slippery. But that's not the only thing. People say, well, does that mean oil is basic? No. Not everything that's slippery is basic. But things that are basic are usually slippery. Okay. They turn litmus blue, as you all know. All right. Now, one more thing I want. This is pretty much wrapping up the notes parts of this. We're about to get to tomorrow. Tomorrow, Friday, yeah, tomorrow. We're going to get to some starting some problems kind of stuff. Although I guess technically that Arrhenius and Bronze there were problems too. You had to figure out which was which. But just wrapping up the notes, I want to talk about one more thing. And I have some examples here of some indicators. I have a couple of examples. We've already seen one. What indicator? A thing that turns either one color or another based on the pH. What have we already seen? Which one did we see? Litmus. Litmus be my lucky day. Yeah, litmus was one. Litmus, I think I told you, comes from lichen plants, grow on rocks, and they're sensitive to pH changes. So they change color depending. They have a molecular change, and they change color depending on the pH, depending on if it's acidic or basic. I have some other things that also turn color. Things that you may be surprised by. Okay, I know she's surprised.
That is creepy.
What is she holding that will exactly tea? Let's see. Goodbye. Let me show you some tea here. That's a little weird now, I know. She may be back later, so just keep your eyes open. Yeah. Well, she was surprised. I'm going to pour some tea into each of these beakers, okay? And I'm going to show you what happens when I add an acid or a base to it. One more, maybe? Yeah. That's good. All right, look here. Here's my tea. Does everybody see it? Turn that light on, maybe? Yeah, probably better on than off. All right, there's my tea. Can everybody see the tea? Yeah, that looks good. Believe it or not, that's looks right on there. Anyway, okay, let's add a little bit of. By the way, do we add acid to our tea? Yeah. What do you sometimes add that will be acidic to your tea? Lemon. And if you ever noticed, you can actually do this in the restaurant. If you add a little bit of lemon to your tea, let's see what happens to it. Oh, do I have a stirring rod here? You want to give me a stirring rod? I don't think I have one. Give me a stirring rod. I'll just swirl it up a little bit. Can you see the difference between that one and the R2?
It's lighter.
It's lighter. Okay, it's absolutely a little bit lighter. All right. So, and then by the way, here I've got a little bit of base. Thank you. Go. Here I've got a little bit of base. And if I add this to here, let's see what happens. May not be as obvious, but it is a little bit darker. See it? Just a little bit, but it is darker. Let me try a little darker, a little stronger base. Yeah, oh, it's clearly darker, but just wondering. So T, yeah, not much difference. T is an indicator, but that's not that exciting, despite our English ladies. Oops, I don't want to give you that answer yet. Despite our English ladies' astonished look. I have something better here. Okay, much better. Let me dump these out and show you. Your clothing would have acid on it. I don't understand. Oh, well, that's a different story. Right. Go get me, Emily, you have nothing better to do. Go get me that piece of red cabbage back, purple cabbage back there. See it? Now just one piece. The piece next to it. There you go. Bring it up here.
It smells better than my feet.
It does smell better than Emily's feet.
It really does, though. I know my feet smell like cabbage.
Now, believe it or not, this purple cabbage, which you've all probably had in a salad or, what were they? I think Mrs. Nora is making coleslaw. with it this week. I took this purple cabbage and I boiled it this afternoon, early afternoon. And what I got was this blue liquid. That's all I did, just boil it with water. And I'm going to pour it into 3 beakers here. Now this, I mean, you saw the tea just turn different shades of the same color. I think you'll appreciate this one a little bit better. All right, watch this one. Let me make sure I can see it good. Can you see how blue that is? Try to light off. I don't know which is better. I really don't. I'm thinking maybe off would be better. Anyway, let's add a little bit of acid. Hey, check this out. This is pretty cool. What? It doesn't turn clear. It turns red. Hey, is he colorblind too?
Actually, he is.
It turned red.
The smell is getting in his head.
All right.
No,
Isn't that cool?
I really am colorblind now.
All right, check this out. Let's add a little base. That was the acid. We'll add a little bit of base to this one. What?
Oh my god.
Oh, the second one.
Now, try it with the light on. See if we can see a difference.
I see absolutely no difference.
I'm not happy with that.
Too intermediary for your eyes.
Probably.
This one is green.
Okay. Well, thank you for
This one is blue. And this one is red.
You can tell that.
Yeah, I can tell.
Yeah, how about we mix them together? Okay, let's do that. You can see it better from over here. Yeah, we got red and green. Yeah. Okay.
Christmas.
Let's put a little red into the green. What? Oh yeah, it's turning color. Yeah. Now it's like olive green. Not quite the blue yet though. Ooh, what's that? Look, that's Kelly green.
Emerald.
Emerald green. Emerald Isle green. Now what do we got? We got a mess. We got a mess. Here, let me throw some of this in here. Keep putting some more of this in. Ooh, purple. Oh, wow, that's teal. That is teal. Look at that. Is that cool?
On my t-shirt.
Ooh, what's that one? I think we missed it. May have gotten past it. Now, that's blue. It's back to the blue it was when it was neutral. A little bit more acid in there. What do we got now? Look at that. Huh? Purple.
It's the same color as your shirt.
Yeah, it's like my shirt color.
Dump it all over. I'm gonna see it.
And all the way back to full red.
Oh, I see that now.
So this guy is a really cool indicator because he turns a lot of different colors depending on the pH, depending on how much acid or base I've added to it. Okay. It is amazing how, it looks refreshingly cool, but it smells like Emily's feet. It really does. It just smells like a
Would
cabbage.
you like to smell like feet? Do you have
No
a
one
remedy?
wants to smell your
Do
feet.
you have a remedy for smelling feet? Can I look it up on Google?
No, there is no remedy. Here,
Do
I'll just pass this one around, and it doesn't look like a great color, but pass it around and take a little sniff of that. Yeah,
Smells like Emily.
it smells like him.
Sounds nice. Grinch.
Great.
Okay.
For those of you, I'm only doing this for those of you who don't sit close enough to Emily to smell her like she always does.
Does it smell better or worse than Emily's feet? Question.
Yeah.
Thank God we're recording this.
Yeah. Now, so litmus would be some examples. Take a look at these examples up here. Litmus, tea. You're copying these, right, Emily? Red cabbage or purple cabbage, we're going to call it. Phenolphthalein is the one. Remember that one? That was what stuff we added. What colors did that turn when we put those drops in those little reaction wells, the circles? Remember what color they turned? Pink. Yeah. They were either clear or pink. And then there's another one we're going to use in the lab we do in the Tums and Rolaids lab. We're going to do a different Tums and Rolaids lab, and that is Congo Red.
Wait, is phenolphthalein?
Phenolphthalein.
Does that have a profuse smell to it?
No. It smells a little bit like alcohol because it's mixed in alcohol.
My feet smell like alcohol.
Yeah, I know. It doesn't look like it should smell like that. It looks like it should taste like Kool-Aid or smell like Kool-Aid. But unfortunately, it smells like Emily's feet. Okay, good enough. Now, I have your homework. I'm going to write it up here on the board for anybody who's absent, and then I'm going to put it over here. But let's write it up here for right now. This homework encompasses stuff from the previous class, because that one we didn't have time. We had time to do the paper at the end, and also this class. So you're going to have, it's not that much, but you'll have questions like Arrhenius and Bronsted acid and base, that kind of stuff, and also stuff on today's. So page 461. Right, that makes sense.
Bow bags are different.
Page 461, numbers 7, 8, 13, and 14.
Wow, where's the concentration camp?
And page 456, numbers 1, 2, 4. Copy all that down, and then I'm going to write on the board.